Hello everyone, welcome to our next lecture. In this lecture, we are going to talk about the concepts of NumPy and we are going to look at how we can use this tool for machine learning and data science. So before I start, I hope that you have covered the previous concepts and you have practiced questions, and also now you are able to create basic, Python functions, etc. So now let's get started with the NumPy and see what we can do with this tool. So before we start NumPy, let's look at the concept of array. So in Python, we have looked at the concept of lists. So we had list here and we were entering some data type like 1, 2, 3, 4 or some other like strings, etc. Okay, but what happens in array, we use unique objects. So like the data type of the object should be same. So if you're entering number, there should be numbers only. You cannot add strings and number together. So an array contains only homogeneous data types. So like all the data types are just same. And what we do, we use array to store information that are of the similar kind. I hope this concept is clear to you. You must have studied the concepts of matrix, etc. in your senior high school or high school. Okay, so there you have worked with certain problems related to matrices. So you can compare this array with matrices. Both are kind of similar, and you won't be confused if you are comparing in that manner. So NumPy basically is a library that is developed by some group of individuals so that we can perform calculations here, mathematical calculations, in a very efficient manner. It is very fast because in background NumPy uses C programming language, and C is quite fast as compared to Python. So NumPy is kind of, you can say, give you the benefit of Python and C at the same time. So C allows you to perform calculations faster and Python gives you the simplicity of writing code. So NumPy uses kind of a technique called vectorization in the background. If you want to read about vectorization, you can study that somewhere. You can search on Google, but that is not important basically. So basically we are going to do we are going to use NumPy library to create array to work with numbers and to perform mathematical calculations that we will be doing when solving machine learning problems, etc. Okay, so why numbers? Because in machine learning or in computer, you can say, will be like we work on text data, we work on image data, we work on video data. So all these type of things, when used in computer, when we bring them in the computer, they are converted into numbers. So computer only understand the language of numbers. So everything is converted into numbers, and after that all the calculations and everything, all the operations that is needed to like give you the input or output is like performed only on the numbers only. So that's why we are using NumPy. I hope we are clear here. So in the collab notebook, I have mentioned the entire definition of NumPy, array, etc. If you want to read, you can read them, and you can get better understanding of what NumPy and array is. But for now, I think everything is clear, and we can move on to the next concept. Okay, now let me give you the concepts of array in more detail. So like we have some dimensions as well, so we are going to look into that particular concept right now. Now let's see, here we have some examples of the array. Okay, so see, we are using array to store information that are of the same kind, so numbers or or it can be any other object type. So here we have mainly numbers only in machine learning. So here I have given you 4 examples, 1, 2, 3, 4. So what we can see here, we have here 3 and 2, 5 total, 5 elements here. Okay, here we have 2 elements, here we have 3 elements, and here we have 4 elements. That means in array we can have n number of elements. We can add as many elements as we want. So it can be 5, it can be 2, it can be 3, it can be 4. That means the only direction in which we are able to add elements is in this direction. That means we are able to add in this particular direction. So this particular direction is called axis 0. Okay, so this is axis 0. The direction in which you are able to add the element is called axis 0. Okay, now these numbers are called scalars. Okay, and this particular direction in which we are able to add this particular these elements, that is called vectors. So this is one dimensional array. One dimensional means we are moving into one direction only. Okay, that is this direction. But if you are just using simple numbers, these simple numbers are scalars because they do not have any direction. Okay, they are not moving into any direction. So this is an example of zero dimensional array, you can say, just simple number. Okay, but we do not do that because array is basically a collection, but you can say a simple number is a scalar. Now see here, in one dimensional array we are able to move into one direction only. We are able to add elements in one direction only. That means we can have as many elements as we want in one direction. We can have one element or two element or three element or n elements, but the only direction in which we are able to add is this direction. Okay, so now here comes the concept of shape. So what would be the shape of this array? So if we have this array 1 2 3 4 5, what is the shape of this array? The shape of this array is 1 into 5. Why this is 1 into 5? 1 represents the row, so this is just one arrow, right? So this is just one row, and this particular thing represents the column. So this is first column, this is second column, this is third column, fourth, and this is fifth. So that means we have one row and 5 columns. So this particular thing represents row, this particular thing represents the column. That means we have the shape of this array as 1 into 5. In the same manner, the shape of this array is 1 into 2. This is 1 into 3, and this is 1 into 4. You need to understand the concept of shape very carefully, because once we move on to the higher dimension, this concept will become a bit complicated, especially for beginners who are not aware about the array, or who are completely new to machine learning or data science. So please remember this, like this is how we can you can say find out the shape. Shape is nothing but row into the column. Once you move into the higher dimension, then there will be layering as well. So let's now jump to the two-dimensional array, and let me give you an example of two-dimensional array. So two-dimensional array is nothing but, you can say, collection of one-dimensional arrays. So in one-dimensional array we were able to add elements in just this direction, right? But in two-dimensional array we are able to add one-dimensional arrays n number of times. So this is one array, this is another, and this is another, you can say. In the same manner you can have n number of arrays here, but we are adding the one-dimensional array in this direction. That means we are not only able to add elements in this direction, we are also able to add rows in this direction. Okay, that means in 2D array we are able to add elements in both the directions, this direction and this direction. Okay, but notice here the building block of 2D array is 1D array, right? So this is 1D array and these are all 1D arrays, and once we combine them we get 2D array. Okay, that means 2D array is nothing but combination of 1D array only 1D arrays, and the direction in which 1D arrays is being added, that is the axis 0. So basically axis 0 will be the direction in which the building block of that particular dimension is added. So here the building block is 1D array, and the direction in which it is being added is the rows. Okay, that means we can have as many columns as we want, we can have as many rows as we want. So this is the example of 2D array. You must have seen the example of 2D array somewhere, like when we create table or when we work on Excel sheets, etc. So there, that is kind of, you can say, an example of 2D array. So 2D array will have the same representation, m into n. So you can say one is row, one is column. Now let me give you an example. So consider here, this is 1, 2, 3, 4, 5, 6. This is 7, 8, 9, 10, 11, okay, 12, let's say. This can, like, you can add as many columns as you want, you can add as many rows as you want here. So this can be any number here, this can be any number, so it's up to you. So this is an example of, you can say, 2D array, right? Now if you want to find out the column, all you have to do is count this is column and this is rows. So based on that you can find out the shape of this particular array. So let's say if we are considering this area only as a 2D array, then we'll have 2 rows, that means 2 into the shape will be 1, so 1, 2, 3, 4, 5, 6, that means we have 6 columns. So this represents 2 rows and 6 columns. Okay, so now you can say this is an example of 2D array, and if I have to ask you about the axis, this is axis 0, because the building block is 1D array and the direction in which we are adding the building block is the axis 0, and then this will become axis 1. Okay, so I hope the concept of 1D array and 2D array are clear. Now let's see how we can create 3D array. So basically you can say 3D array is a combination of 2D array. So we have 2D array here, and in 2D array we were able to add as many rows as we want, as many columns as we want. Okay, so in 3D array what we do, we will be able to add as many 2D arrays as we want. So it's kind of like there will be layering here. So let's say this is behind this particular array, and we are able to add as many arrays as we want, 2D arrays. So this is, you can say, in this manner we are able to add the layers. So this is not just one sheet, we have combination of the 2D arrays. So the direction in which we are able to add the 2D array will be axis 0. Okay, so this will be axis 0, and in this 3D array we have the freedom to add elements not just in this direction, but we also have a new axis, a new, you can say, direction. So first we are creating the basic scalar elements in the array, 1D array, then we are forming rows. After that we are doing this layering. So that means what we are doing is we are using this combination, something like this, you can say x, so let's say x or y and z. So if you are saying z is the column, y is the row, and then x will become the layers. There are so many layers here, so you can count them. So let's say here we have 1, 2, 3, 4 layers, right? So this 4 will go here. Then we have 1, 2, 3, 4, 5 columns and 1, 2, 3 rows. So this is 3 and 5. So this will become the shape of this particular 3D array. So this is how you can find the shape of this particular 3D array. So basically this is your layer, how many layers are there, then your row, then your column. Okay, so this is the shape of 3D array. In the same manner, if you are moving on to the higher dimension, let's say 4D array, then in 4D array there will be 3D as the basic block, building block, and in the same manner once you're moving to the fifth dimension, then there will be 4D as the building block. So we won't be able to like draw or like show you using the diagram how 4D arrays will look like, but we'll definitely like create an example and see. Okay, so basically if your concept here is clear, if you're able to understand how the building blocks are created and what is axis 0, then you can actually understand the concept of shapes, etc. Please try to rewatch this entire section once again if your concepts are not clear, because things will become a bit confusing, a bit complicated for you if you are like skipping this part, if you're thinking that this is just a simple concept. But it's not, believe me, because your concepts will be like like you'll be confused after a while, like you'll have to like go back and revise everything once again. So that's why it's better to like revise, try to create on your own, take a pen and paper and try to create and find out the shapes, etc. for 1D, 2D and 3D array. So in the previous lecture we have studied the concept of classes and object-oriented programming, right? So from there we know that we can create our own objects and we can develop methods and attributes for that particular object that we have created. In the same manner, NumPy is a library that is created on object-oriented programming, okay, in Python. So it also has some object and its type, okay. So this particular object type here is known as numpy.nd array. That means the array that we use in NumPy has this object type, numpy.nd array. Okay, now it also has certain attributes. Attributes means like we already talked about the characteristics, and it also has some methods that we use to perform certain calculations here. So there are so many methods in NumPy. We are going to look at a few methods. If you want to access, if you want to see or learn about other methods, then you can simply look into their documentation. But don't worry, you don't need to remember everything, don't need to follow every other method. If you need to use any method, you simply have to just visit their documentation or search on Google. So you just need to understand the basic concepts. Now let's see how we can create an array in NumPy. So let's say you want to create an array, okay, of one dimension. So what you are going to do is you are simply going to write this function np.array and you are going to enter your array in this format. Okay, just note that this should not be more than one object argument. That means here either it should be in this format or it can be just a simple number. It can be simple number. It cannot be np array 2 3 4. It cannot be like that because it only accepts one object argument. This will result in error. Okay, so make sure to keep this thing in mind. Here you won't be getting any error because you are combining everything in one bracket. That means it is considering it as if it is just a single object argument. Okay, in the same manner, if you want to create 2D array, all you have to do is create a bigger bracket here, and then in the bigger bracket you can enter the 1D array. Okay, that way you will be able to create 2D array. And in the same manner, if you want to create 3D array, all you have to do is combine everything in one bigger bracket, then after that your 2D array, then 2D array, then 2D array. Okay, so that way you will be able to create your arrays in NumPy. So make sure that this accepts only one argument, and after that, not one object argument. After that you can also enter d type and just tell NumPy that I want this particular array to be either integer or complex or whatever, like so there is a d type as well, so you can like state this particular array should be in this particular d type. Okay, so this is how you can create that. Now let's visit our Colab notebook and see how with the help of code we have created different dimensional arrays. Okay, one more thing that I forgot to mention, that even in Python there is a basic concept. There is a method that will allow you to create basic array, but NumPy has this benefit that in NumPy you are able to work with n-dimensional arrays, so that is not possible with the basic Python array. So NumPy will allow you to work with n-dimensional arrays, so that is the benefit of using NumPy. Also for like complex mathematical calculations, NumPy is very efficient and fast. So see here, first of all you have to do is you have to just import the NumPy library here by import NumPy as np. So this is an alias name that we use so that we don't have to use the full name NumPy. So this is the name that we are using. Then here we are simply creating a simple, like we are just working with the scalar. So let's say we just entered this particular number 2, then output will be 2. Okay, this will also be considered as array, but you can say this is just a 0-dimensional array. This is kind of like, you can say, meaningless, but just know that if you're creating with the help of np.array, then this will result in an array only, and the type of this particular output will be numpy.ndArray, because it is an object, okay, created by NumPy. Now let's see what are the attributes of that particular object. So we created one-dimensional array, then we have this attribute called shape, we have the attribute ndim, dtype, size and item size. So shape, as we talked about, shape is the rows, column, etc. ndim is the dimension, that which dimension it is, okay, and the dtype is, you can say like whether it is int 16, int 32, int 64, etc. and the size you can say is the number of elements there. So if here we have one-dimensional array containing 1 or 2 here, then the size will be 2. Okay, this is just the count of the number of element in that particular array. So here we have only one element, so this is just 1. And the item size is nothing but d type divided by 8. So if d type is here 16, then the item size will be 16 divided by 8, 2. Okay, so that is just 64 here divided by 8. So that you can say that is the item size. Now see here, the shape here is no shape, because this is 0-dimensional array. The dimension here is 0, that means it has no dimension. Okay, size is 1, because this is total number of elements in this particular array is 1. So this is how you can figure out. So if you want to like understand the definitions here, you can just read this particular comment that I have written here. So the dimension is the dimension of the array. For a matrix with n rows and m columns, shape will be n m. The length of the shape tuple is therefore the number of axes ndim. dtype, an object describing the type of the elements in an array. Size of 1D array, total number of elements of the array. Okay, if you can like understand this, that's fine. If not, just try to read these comments. Here we are creating one-dimensional array. One-dimensional arrays are also known as vectors. So here we have defined this 1D, and after that we have used this function np-array, and then we have used this bracket, and after that we have entered the number of elements we want to add. Okay, so this will give you this particular output array. Now if you want to check the attributes, then we have this type of 1D is numpy.ndArray. Shape is 5. This 5 comma means 1 into 5. This is simply means we have 1 row and 5 columns. Okay, this simply means we have this 1 row and we have 5 columns, 1 2 3 4 5. So I hope the concept of shape is clear here. Then if you want to check the dimension is just 1, because in only one direction that we are able to add this add the elements here. Okay, these things are not necessary, but if you want to check the size is the total number of elements. So we have 5, so the output is 5. Item size is nothing but d type divided by 8. Okay, now let's create a higher dimensional array. So the next dimension is 2D. So if you want to create 2D array, you have to add a bracket here. If you are not adding bracket, if you are simply writing arrays by writing one array after another here, one after another, this will result in an error because you haven't added any bracket here. So that is the reason here, because it only accepts a single object argument. So the moment we added a bigger bracket here outside, and after that we entered our list of arrays, then the output is this. Okay, that means to create 2D array, all you have to do is create a bigger outer bracket. After that you start adding 1D array, and this will be treated as row. So this is one row, this is second row, and these elements will be treated as column. So 1 2 3 4 5, so this is 5 column, this is also 5. So make sure these elements are equal in number so that you don't get any error. So this should be equal, and the moment you click this, execute this particular shell, you get this particular output. So that means we have 1 2 row and we have 1 2 3 4 5. So that means 2 into 5 will be the shape of this particular array. Now let's see the attributes and what we have here. So the type is numpy.nd array. The shape is 2 into 5, that means 2 rows and 5 columns. The dimension is 2. D type is int64. The item size is 10. 10 is 5 5 10. Now if you want to create 3-dimensional array, so 3-dimensional arrays will be created only if you are adding a bigger bracket outside the 2D array. So here, just by adding the rows won't create a 3-dimensional array. So here we have added another row, so this won't create a 3D array. This is a 2D array only. Okay, the dimension here is 2D only. The shape here is just 3 into 5. Okay, this is not creating a 3-dimensional array. Why? Because this bigger bracket outside is missing. Now if you are adding this bracket here, bigger bracket, and then you are adding this particular 2D elements, okay, then this thing will result in a 3D array. So here what we are doing, we are adding just 2D arrays twice, one and here twice, and in the 2D array we have 1D arrays. Okay, 1 2, and then we have scalars there within that. So the way I have explained the concept previously, here we are able to see the example of that. Okay, so make sure that you are adding brackets here. The moment you are moving to a bigger dimension, all you have to do is add a outer bracket, and within that bracket you have to add the lower dimensions. Okay, now see, this is the output of the array that we created, 3D array that we created, and the shape here is 2 2 5. That means we have 2 layers, 2 rows and 5 columns. So here we have 2 layers. This is first layer, this is second layer, and we have 2 rows for each 2-dimensional array. So here we have 2 rows okay, and here columns are 1 2 3 4 5, okay. That means it starts with column, then row, then layers, okay, the moment we move on to higher dimensions. So this is how you can understand this is 5 column, 2 rows and 2 layers. So 5 columns, 2 rows, 2 layers. So that way you will be able to understand, like try to visualize the output, the shape in your mind, so that you can build that intuition that this is the thing that is happening in the background. Because the moment you start moving on to the higher dimensions, you will get confused, like how the shapes are working and how the dimensions are working, etc. And especially when you are working with those matrices, you will be able to figure out what exactly is happening, how to consider the shape, and how to perform certain methods. So that way, that's the importance, you can say, for visualization. So try to visualize things in your mind. So I mentioned that we can specify if you want the array in a particular type. So here let's say D type is complex, so the array will be in a complex format. So here all the elements are complex numbers. So you can also specify D type, whatever D type you want. So NumPy offers us various methods to create different types of arrays. So let's say you want to create arrays full of zeros. Okay, so you just have to use np.zeros, and then after that you have to define the shape of the particular array, and this will be the output. So let's say the shape is 3 4, then this will give you the output 3 rows 4 columns. So these type of arrays are used just in situations where the original value is unknown, okay, but the size is known. So in that case, like you can use these methods to generate a array, and after that you can update the array with the actual value. So in the same manner, you have np.ones that will create you array full of 1, okay. So you can see the output here is in float format. So whenever you are using these methods, the output will be in float format only. So if you want to change the D type, you can simply specify that this is the D type that I want to use here for the output, then the output will be in that format. So there is another method called np.empty. So here it will create you array whose initial content is random and depends on the state of the memory. So you can say this will give you an output array where each element represents the memory state, okay. In the same manner, if you want to create 3-dimensional arrays and you want to specify the D type, then you simply have to write the method, specify the D type, and the output will be in this format, okay. Now in Python there is a concept called range function. So what range does is, range will actually create you the range of numbers between minimum to maximum value, and there is this the step size that you can specify, and this will actually give you the number between including 1 but excluding 10. So this will give you the output here. In the same manner, we also have the concept of range in NumPy. So NumPy will give you the range of array in that particular whatever range that you have specified. So let's say here you have specified that you want an output array between 10 to 20 with the difference of 3. So like if you're jumping from 3 states directly, then this will give you the output in this format. So 10 to 13, 13 to 16, 16 to 19. So this will give you the array in this format. So you can use this method whenever you feel like you need to create array in that format. So you can simply use this particular method, np.arrange, okay. This is not double R, this is single R, so remember that thing in mind. Now if you want to use the float, then also you can create that particular array, but what happens is you do not have control over the output. The number of elements that will be here, okay, that will be in your output. So you do not have control over the number of elements in your output when you're using floats here, 2.4, 10.5, and you are specifying this step size of 1.2. so the output here is like any output, any number, okay. So you do not have control over the output. To get rid of that particular situation, what we do, we use another inbuilt method called linspace. So linspace will basically give you the output by specifying here the number of elements that you want in your output. So let's say you want, you know, output as 9 elements and you want the output between 2 to 4. So this will give you the output in the float format only. So this is applicable only in the situations when you are using float arguments. Okay, so in that situation you can simply, like, you know, specify that this is the number of element that I want, and these are the numbers that will be there. So this will give you the 9 outputs, 9 elements in your output. So 1 2 3 4 5 6 7 8 9. So that way, like, you can use this particular method. Also, when your, like, matrix is quite huge, then Python, like, you know, Python will automatically hide all the elements and it will show you just, you know, a short version of that particular output. So just in case, like, you know, you want to see all the elements, all you have to do is, like, you know, install another library called sys, and after that there is a method that is mentioned in the documentation of the NumPy that you can just look, but that is not important. You don't need to actually, you know, see all the elements, so don't worry about that. We'll see how we can see the element at a particular position later on when we are working with the indices and slicing. Now we also have a method for random, you know, random generation of arrays. So all you have to do is, if you want to create array between 0 1 1, here if you want to print random arrays between 0 and 1, you can simply use this function np.random.rand, and in the argument you can use the shape of that particular array. So here the shape is 2 rows and 3 columns, so the output will be between 0 to 1. Okay, now there is another function called np.random.random, and here also you can enter the shape, but the shape should go in this single argument. So here you can see there is another bracket, but here the bracket is missing, so there is a difference here. So rand and random has a difference here. So try to, you know, like, understand this, that here we are only entering one positional argument, but here we have 2. Okay, in the same manner we have np.random.randint, and here all you have to do is mention the range, okay, and the size of your particular array. So this will, like, you know, give you between 0 to 10, and the output will be in this format, and number of elements you want, so it will generate randomly from this particular, you know, like, you can say integer. So it will give you the output in this format, so 0 to 10 and the size of that particular array that you have specified. So these are just the method that we have seen previously. Like, if you're familiar with Python methods, then you can simply understand method of any object anywhere, no matter which library you are using. You can simply understand the concept here. Now see, if you want to, like, generate a random number between, you know, like 0 to 1000, and the size here is 10 to 4, so this will give you this particular output. So you can use this particular, you know, method to generate random number in this format. So, like, there are various, you know, methods that you can use, just understand. So if you want, like, you know, further explanation on these particular methods, you can simply visit this particular link and find out you know, more about these functions. So in machine learning you will come across the concept of np.randomSeed, okay, most of the time. So whenever you are working with random arrays, you will have to, like, you know, specify this np.randomSeed. So not just in array, but whenever you are using random function anywhere, whenever you are creating something randomly, let's say you want to create data sets and you want to divide them, you know, randomly. So you can say there we use the concept of random seed. So this number 42 is, you can say, a convention, but you can use 0, any number, so that does not matter. The thing is, whenever you are running this code, it will result in same output every time you run this particular, you know, code. In the same manner, if you are writing the same code again, this will be the same output as before. So that means we are able to preserve the consistency with the help of np.random.seed. Okay, if you are not using that particular line of code, then what it will do, it will create different output every time you run the particular code code cell. So just try to understand the difference here. So see, here we haven't used np.random seed. The output here is completely different as compared to this one. So you can see the difference between these two. So the outputs are completely different. So that is the beauty of np.random seed. Now let's look at the basic operations that we can perform in NumPy. So just like Python, we had addition, subtraction, etc. In the same manner, you can also perform those operations on NumPy array. So what happens is, when you're performing these operations on NumPy array, everything takes place element wise. So let's say if I am subtracting a minus b, then all the element at that location will be subtracted from that particular location. So like here 1 is there, here 2 is there, so it will be 1 minus 2. This will be done between these two, this will be done between these two, and this will be done between these two. That means we are having element wise operation here whenever we are doing that. So if you are adding a plus b, then output will be 3 1 and 3 5. That means 2 plus 1 3, 1 plus 0 1, okay, 0 plus 3 3, and 1 plus 4 5. So in the same manner, we have a plus b, a minus b, the output will be in the same manner. So the operations are actually happening element wise. Okay, now we also have the multiplication. The multiplication will also happen element wise, but you must have studied the concept of dot product mathematics like class. So dot product also happens, but for the dot product you have to use this special symbol here. Okay, so the moment you use this special symbol, then dot product will take place. Okay, or you can simply use this particular method if you want to use the concept of dot product here. So dot product and normal multiplication are two different things. So normal multiplication means element wise multiplication will take place, but in the dot product, the matrix multiplication that we have studied in our previous mathematics classes in high school or senior high school, in the same manner, like the matrix multiplication will take place using these two @ sign or the dot method here. So if you want to square the elements, you can simply use this particular the same approach that we have followed in Python. If you want the division, you can do that in the same format. Okay, if you want floor division, it can happen in the same format. Okay, if you want exponential, then you can also use NumPy inbuilt functions. So like there NumPy also has various inbuilt functions to calculate these particular basic calculations. So you should prefer NumPy methods rather than using the basic calculation, the symbols, etc., because NumPy methods are quite fast and efficient. So that's why you should prefer those inbuilt methods in the NumPy library rather than using the basic Python Python approach here. So if you're using np.exponential, this will calculate the exponential. If you want to take the log, then you can simply use np.log and enter the array here. So this will give you the log or the exponent. So you can see everything is taking element wise. So it is calculating the exponent of each element and then giving you the output in this particular array format. So try to understand here that every operation is taking place in element format. Now if you want remainder, you can also use this basic Python approach. If you want square root, you can use this inbuilt method np.sqrt, and then you can enter your array. This will give you the output here. If you want to add, you can use inbuilt method np.sum. If you want to find median, then you can use this particular method. Then if you want standard deviation, you can simply use this concept. If you want mean, max, minimum of that particular array, then you can use these methods. So this is just the basic inbuilt mathematical functions that we can use, and you can simply just try to practice a little bit so that you can remember these methods. And if you need help, like let's say you forget certain methods, then you can simply search on Google, or you can visit the documentation and find out the methods that you want to use. So this will give you the index of the maximum value, argmax. This will give you the index of the minimum value. So index is calculated like the first element will be associated with 0, then second element will be the 1, the same method that we have studied when we were studying list, etc. Okay, so these are certain methods. If you want to like transpose the matrix, transpose means if you want to like rearrange the column to rows, so this will give you the transpose. You just have to use this array name dot t, so this will transpose the particular matrix. Okay, the b here is 2034. When you are using b dot t, what's happening is we are simply like writing these 2 3 here and then 0 4 here. So like it's kind of like this particular column goes here as rows, and that particular column comes here as the another row. Now we also have comparison operators. You can simply use comparison operators. All the operations will take place element wise. That means all the element of A will be compared with all the element of B at that particular position, and the output will be in this format. So you can simply use that. And if you want to like try out on your own, you can simply write two arrays A and B using this particular Colab notebook on your paper, and just try to to do the comparison and find out the output and match the output with this particular result, and see whether you are able to understand the element wise operation or not. I hope this concept is simple, and you don't need to understand everything like from the start, because you already have studied most of the concepts. So these are like basic mathematical methods that you can simply use. So if you want to do the sum after comparison, you can use this approach as well. If you want to sort all the elements of that particular array or matrix, then you can simply sort it. So matrix is nothing but, you can say, a 3D array. So if you want to sort, it will sort all the elements in this particular manner. So 0 2 3 4. Okay, if you are stuck anywhere, like if you feel like I'm not able to understand the concept behind a particular method, all you have to do is type that particular method on Google, and it will give you many results, and then you can visit any page and just try to understand everything. But you don't need to like understand all the methods or remember all the methods. As I mentioned previously, all you need to do is just use those concepts in your practice projects, and the moment you start solving the problems, you'll be able to understand how to use certain method, how to like find out certain methods in your NumPy documentation. So just you should be able to find out the methods, and you should be able to use them whenever required. Okay, now let's look at the concept of reshaping. So here, let's say we created an array in this format. The shape here is 3 4. Okay, now you want to do the reshaping. So let's say you want to reshape this particular output. Let's say this is 2D array, right? This is 2D. You want to reshape it into 3D. So to convert it into 3D, all you have to do is use this particular method, s dot reshape 322. Okay, that means what we are doing here, we are converting it into 2 columns, 2 rows, and 3 layers. So the output here is, the output here is this. Okay, that means from 2D we converted it into 3D. So just remember that whenever you are doing the reshape, all you have to think that the multiplication of these elements, the numbers, should be same. So this is 3 into 4 is 12. So the number of elements are 12. Here also the multiplication should be equal to 12. Then only you will be able to reshape. If you are entering some other different numbers here, then it will result in error because you are exceeding, or you are not able to reach that particular element number. So just try to keep that thing in mind. So reshaping error can occur. So just here also we can reshape by checking if the multiplication here is 12 or not. So 216. So all the, you can say, permutation and combination that are available for that 12, in that approach you can create that particular matrix. So here 12 into 1. So you can say, if you want to study about the more functions, I have mentioned the link here. You can visit the documentation. You can figure out on your own what are the other methods there. Also, just in case your mathematical concepts are not clear, basic mathematical concepts related to matrices are not clear, just try to revise them and try to see what is dot product and how matrices multiplication, addition, subtraction work, because NumPy is similar to matrices in your mathematics. Okay, so just try to revise your previous concepts, although we will be launching complete mathematics books, but the concepts explaining that particular book will be right from where you have left. So let's say you have completed basic understanding of calculus, derivatives, etc. Then only focus will be to start from that particular level. So we'll start covering the topics after that particular basic concepts. We won't be doing it from the scratch, but obviously we'll be giving you a basic revision, but not complete concept. So just try to visit your previous mathematical concepts, just try to revise through them so that you can work on the matrices. Now let's see how we can do the dot product. So I think I should explain this concept to you, because when we are covering the concept of broadcasting, then this particular concept will come there, and I don't want you to get confused. If you are not aware of the dot product, just try to understand this. So let's say we have this particular first row here, okay, and this row here. So what will happen, this particular first row will first multiply this. So this will be 2 into 1 plus 1 into 3, okay, and then this first row will multiply here. So 1 will be multiplied with 0 and 1 will multiply with 4, okay. In the same manner, this will be multiplied with the first column here. So 0 into 2 plus 1 into 3. So that means first element you multiplied by the first element only. Then again this will be multiplied here. So this will be 0 into 0 plus 1 into 4. Now if you are checking calculation, it will be 2 plus 5, 2 plus 3, sorry, 5. This will be 0, 0 plus 3, 3, okay. This is 0, 0 plus 4, 4, 0, 0 plus 4, 4. So this is the same output here, right, that we received using this formula, @ or dot. So just try to go through the concepts, and you will definitely understand. So I hope the concept of dot product is clear here. Now let's look at an important concept in NumPy called broadcasting. So what broadcasting is? Broadcasting is, you can say, a way in which NumPy actually performs the element-wise operations, okay. So the term broadcasting describes how NumPy treats arrays with different shapes during arithmetic operations. Subject to certain constraints, the smaller array is broadcast across the larger array so that they have compatible shapes. That means in NumPy, shape compatibility should be there in order to perform any arithmetic operation. So here we have two arrays, this and this. Now this is the smaller array. So what's happening here is NumPy is broadcasting this smaller array in such a manner so that this becomes of the similar shape as this one, the first one. Okay, so this is broadcasting here -1 0 1 -1 0 1. So it's kind of like the rows are being copied in a manner so that the shape of this particular array becomes something similar to this one. After that, the element wise operation takes place. So after that, we are multiplying 1 into -1, 2 into 0, 4 into -1, 5 into 0. So that way we are getting this particular output. So broadcasting, you can say, is an internal operation that takes place. That is kind of, you can say, a rule defined by NumPy in order to make the arrays shape compatible and to perform arithmetic operations after that. Okay, if your shapes are not compatible, it will result in an error. Now let me show you some examples and explain why this thing is happening and what are the rules to broadcasting. So here we have two arrays, A and B, 1 2 3 4, B equal to 1. Now shapes here are 1 into 4 and the shape of B is nothing, that means 1 into 1, that is just a single element. Okay, now the operation here is taking place. After that we have C equal to np.array 2 3, the shape here is 2, that means 1 into 2. The A plus C is giving this particular error. Operand could not be broadcast together with the shape 4 2. Why it is happening here? Because so the shape of A is 1 into 4, right? The shape of B is 1 into 1, or you can say nothing. Now the shape of C is 1 into 2. The shape of C is 1 into 2, right? Now what's happening here is A plus B is not giving error, not giving any error. Okay, that means this is fine. Okay, but A plus C is giving us the error. Cool. Now the reason why is the rules to broadcasting. So what happens is there should be shape compatibility in order to perform the operations. So A equal to 1 into 4. The rule of broadcasting is 1 can be equal to any number. Okay, 1 can be compared with any number and it will be compatible. Okay, that means this will be compatible with any number. Any number can be compatible with any number. Okay, but two different numbers are not compatible. Okay, and this is just for the shapes. When the shape, the output that you receive. So this is the output that we receive here, 1 into 4, 1 into 1, 1 into 2. Now here what we can see is in A 1 into 4, okay, and B is 1 into 1. Now according to the rule of broadcasting, we have 1 equal to 1, right, and 1 can be equal to any number. So this particular thing means the shape is compatible. Okay, the shape is compatible here. Again in C what we have, 1 into 2, 1 into 4. Now here 1 is equal to 1, fine, but here 2, here we have 2, but and here we have 4. That means 2 is not equal to 4. Okay, 2 is not equal to 4. Just know that this is n1 should not be equal to n2. Okay, that's why I have used this particular emoji. So 2 is not equal to 4. So according to the rule of broadcasting, two different numbers cannot be equal. Now I hope this concept is clear to you, because this whole thing will let you decide whether that particular error will occur or not. So if you have any other matrix with different shapes, then just ensure that either that particular number at that location is equal to the number in that particular matrix that we are performing operation on, or either it should be just 1. So let me show you some other examples, and this concept hopefully will become more clear to you. Now let's say we have D, okay, an array D. This is of the different dimension. The shape of the D is 2 1, 2 into 1, okay, and the shape of 1 was 1 into 4. Now this operation will take place. Why? This operation will take place. Why? Because here we have 2 into 1, D equal to 2 into 1, and A equal to 1 into 4, right? That means 1 can be equal to any number at both the places. That means there is no shape compatibility issue. So this operation will take place and you will receive this particular output. Now let's create another array and see what is happening. Now the shape here is 2 into 5. We have created an array E equal to np dot array, and this is our input, and the output here is 2 into 5. The shape of A is 1 into 4. The shape of E is 2 into 5. 1 is equal to 2, but 4 is not equal to 5. That means there will be shape error. So these two are not compatible when it comes to the operation, arithmetic operation. So operands could not be broadcast together with the shapes 4 to 5. That means broadcasting is not taking place. Now let's say we have an array F, np array 1 2 3 4 6 7 8 9 1 2 3 4 5 4 sorry 1 2 3 4 1 2 3 4. Now A plus F is happening. The shape of F is 5 4, and the shape of A was 1 into 4. So that means we have 1 equal to 5 and 4 equal to 4. So that operation will take place. That's why this is happening. I hope the concept here is clear. You have to just compare the shapes and see if that particular shape is equal to 1, equal to 1 or that particular number. So the places should be same, either the elements. You can also perform any other operation you want. So I hope this particular concept is clear to you. All you have to just remember is that you have to compare the shapes and see one is equal to any other number or not, and whether that number has the same number in another shape or not at that particular place. If there are two different numbers, then it will create error. Okay, so this is something you have to remember. One more thing, what happens in the background, NumPy actually adds 1. So there is a rule to add 1. So here basically when we are coming from mathematical background, we already know that this is how we can write 1 into 4. But when you are in NumPy, the output here was just simply a single number. Okay, it was something like this, but it was not saying it is 1 into 1, right? So in order to do that thing, in order to perform that operation, all you have to do is you can say figure out on your own. So you have to write 1 to the left. So all you have to do is write as many ones as you want. Okay, then whatever is the actual output, and then you have to compare this with the shape of that particular array. Okay, and that way you will be able to make it more compatible. So here let's say, and also you have to compare it with the array that is the biggest one. So if let's say A equal to, the shape of A is equal to 1 2 3, or let's say something else. Okay, let's say 3 4 5. Okay, now the shape of B is, let's say 2 3, or sorry, let's say 4 5. Now what you are going to do is you are going to write 1 to the left. Okay, no matter how many elements are here, all you have to do is write 1 to the left, and then start comparing them. So this is just a simple basic, mathematical intuition, you can say, that you already know about. So you don't need to remember this thing, but still just you should know that how you can visualize this thing when you are dealing with the shapes. So whenever you are getting any shape error, try to compare the shapes and figure out on your own, okay, why the shape error is occurring, what could be the reason, and how I can do that, fix that. Now let's look at the concept of indexing and slicing of NumPy array. So we have already studied the concept of indexing and slicing in our previous lecture in Python, lists, etc. So this array actually works in the same manner, but there is a few things that you need to remember, or you need to practice basically, because only by practicing you will be able to understand the, you can say, concept behind that. Because once you start writing the code, you will see, yes, this particular array works in this particular manner, because array can be of any dimension. When you are working with the single dimension, a vector only, what happens is you treat you can compare it with the list. But when you are working with multi-dimensional arrays, then in that case you have to visualize things in a completely different manner. So let me give you an example of one-dimensional array and see how indexing works. So here we have an array 1 2 3 4 5. At the index 0 we have 1, index 1 we have 2, index, and if you are doing the slicing, then it will give you 1 2. Slicing means the right side element won't be counted, only 0 1, okay, and these two 0 and 1 will be the output, no matter what you are writing on the right side, but on the left side that will be counted. Okay, so I hope this concept is clear to you. Already you all know this because you have practiced the problems related to lists. Okay, now let's see, if you are doing 0 to 4, then this will give you the output 0 1 2 3 4. This will give you the output till 4. Now if you are taking in account your step size, then this will give you 1 3. 0 to 4, this will only start jumping from 1 to 3, okay, and this will give you this particular output. If you are entering -1, this will give you 1 2 3 4, excluding the outers, the last element. If you are writing -2, this will give you this particular output. If you are writing -1, this will give you this output. Okay, -1 means the element at the last index. Now let's create an array, a three-dimensional array BC. The array here is 4 8 4 9 6 3 2 9 4 5 8 9, and this is another layer here. And if you are checking the index at the 0, now as you can see, the index 0 is this particular two-dimensional array. That means the building block of the 3D array is two-dimensional array. So the building block will be the output when we are considering the index. So when you are working with 2D array, the building block will be 1D array, and the 1D array will be considered at the, you can say, index position elements. So at index 0, the first 1D array will be the output. At index 2, the another. So in that manner you can visualize, okay, how elements are considered in multi-dimensional array. So here your element is at index 0, this two-dimensional array. Okay, now in the same manner you can visualize 0 to 1. So this will only give you the first element. The first element is the 2D array. If you want all of them, you just have to enter this particular thing you will give. After that, if you want to access the element within that two-dimensional array, within that building block element, then all you have to do is add another. This will give you the first array. If you want to access the element within that, then you have to add another this index, and this will give you this particular output. So that way you will be able to access elements within the elements. Okay, so just try to practice these things, because this may be confusing a little bit. And yeah, now this is something new. So here what we are happening is, first of all we are taking both the array. After that what we are doing is, after that we are just taking the first element, you can say here. That means we are taking into account the first element of the first rows. So this will give you the output as this and this. Okay, so here you are writing this column 1, that means you are taking the first element of this particular element. So that way you will be able to get this particular output for both the rows. So just practice this thing. If you are writing this BC, okay, 1 2 3 and then 2, so that means what you are doing is, you are saying take all the elements, after that give me element of the row 1 and 2, okay, 1 and 2, not 3, 3 won't be included, and then give me just 2 columns, okay, just 2 columns. So after that 2 columns will be considered. So the output here is 6 3 4 5 3 2 0 0. Okay, so see here. So what you are doing here is, you are taking these 2 rows, okay, because this is at 1 and this is at 2, okay, this is at 1 and 2. So you are taking you can say 2 rows, and what you are doing after that, you are saying just give me 2 columns. So 2 columns here will be these first 2 columns. Okay, so I hope this concept of slicing is clear to you, very clear to you by now, because only then you will be able to work on multi-dimensional array slicing, because this is what is happening. If you know that you are able to visualize things, then you will be able to easily grasp this. So just try to understand. This will work with the columns, this thing will work with the rows, and this thing will work with the dimensions. Okay, so try to practice this, because without practice you will not be getting anything. In the same manner, if you are writing this BC 1 1 2, then this will give you 4 8. So this will just give you this particular output. In the same manner, if you are writing BC this, that means you are taking first all the elements, all the 2D elements, and then after that you are just taking the 2 rows, and then after that you are taking all the elements of those 2 rows. Okay, so this will be the output. Now we have already talked about that. We'll give you an example of 4D array. So this is how 4D array looks like. So here we have used this random function to create the 4D array, and shape we have defined here is 2 3 4 5. Now let me show you how to know what is the dimension just looking at the array. So all you have to do is count the number of brackets here, 1 2 3 4. So this is 4D array. When you have 3D array, the brackets from the starting will be 1 2 3. So just try to count it in that manner, and you will be able to see that this is a 4D array. So now let's see the basics here. So in the 4D array, what we have here, we have this 3D array, okay, and we have another 3D array here, okay, and within the 3D array we have 2D arrays, 3 2D arrays, 1 2 3, and here we again have 1 2 3 3D arrays. Sorry, yeah, okay. Now within the 3D arrays we have these 2D arrays, okay, and within the 2D arrays we have this 1 rows, this 1D arrays. So as you can see, the 4D array combines all the previous dimension, and the previous dimension to 4D, that is 3D, becomes its basic building block. And I hope that you will be able to figure out the axis 0 now. Okay, you can visualize, kind of like, if you can visualize, because I have already explained the concept of axis 0. Now if you want to do the slicing on this particular matrix, you can also perform the slicing and you can check the output here. So all you have to do is like use 1 2 3 4 here. This will be considered for the column, this will be considered for the inner dimension, okay, and then again this will be just the another dimension, then again the like other dimensions. So you can say columns, rows, and then your dimension, then again your next like layering, you can say, and then another dimension. So whatever the name is, so you can simply like if you want to like visualize, you simply have to try writing a few codes here. Just understand the basics of the slicing first, and then after that perform the calculations and see what is the output, and try to compare and figure out according to the elements of the particular row. So when you are getting this particular output, just try to see how the output is coming, how the Python is giving me the output, and what are the things that it is like considering before giving me the particular output. Because once you can like read through this particular output and try to visualize things, you will become more confident about the concept of slicing here, multi-dimensional slicing. So just try to like practice this multi-dimensional slicing, because this is something like you can understand only by writing down the code. It's hard to like explain everything and explain and give you the exact thing that is happening behind the scene. So just try to write the code and try to visualize on your own, because this is not very difficult if you have already worked on the problems related to slicing. Okay, now here are some extra functions. A equal to np.arrange 30, b equal to a dot shapes 2 minus 1 3. Here you can use -1, means it will input any number. So as I told you that the multiplication of the reshape should be equal to 30. Okay, that means here 3 into 2 6. Now what you need in order to bring that particular output, so whatever the element will be, it will be used here. That means here we are adding 5 in place of 1, so Python will automatically put 5 here, so that the output will be 30. So 1 2 3 4 5, which you can see. So reshaping happens in that manner. You can use -1 here. Now we also have v stack, h stack, the concept of h stack if you want to like arrange to array in the stack manner. So you can simply use this particular method, and here instead of v stack you can use h stack, that will do it horizontally. This is vertically, so it's kind of like these two arrays are being stacked here, 0 2 4 6 8 0 1 2 3 4 8. Now I have explained the basic concepts to you, and I have also like mentioned the links here. You can visit the links and practice a few things, you can learn a few things, and I have also mentioned the link to the practice exercises, the questions that are important to NumPy, and just feel free to practice them. Thank you so much for watching this video, and I hope the concepts explained here are clear to you. If you are still confused about something, feel free to comment, or just reach out to us via Discord and mention your inquiry. Make sure that you have access to this particular Colab notebook and you are going to practice all the code and all the questions that are mentioned there. Now we'll be covering the concept of pandas and other libraries. The concept of library, or the all the structure that we like follow along, will be more clear and like you can say a lot easier for you if you already know the concepts of classes, because almost everything that we develop using Python has the concept of objects, concept of attributes, concept of methods. So just try to be clear about the concept of object-oriented programming, and you will be able to understand any library very easily. You can even read their documentation and you will understand what are the things there are that we can use. Also, you don't need to learn everything about the NumPy or any other library. All you need to do is understand the basic, and you should be able to figure out where to find the thing that you are looking for. That means you need to understand the tool, you need to be able to use that particular tool. Obviously basic things are needed. Like you need to be good at basic things like creating an array and working on arrays, and you should be able to understand how arrays are working, how arithmetic operations are taking place behind the scene. So just like you need to have that basic understanding in order to proceed further in this particular course. So be aware about the tool, know that when and where to find the answer that you are looking for, and just understand that you don't have to remember everything by heart. So that is like something you need to consider and remember always. Also, we'll be launching a book, an ebook, that will help you understand the basic concepts of mathematics related to machine learning and data science. So just make sure to subscribe to this channel and stay updated, because we'll be posting the link here in our Discord community. And yeah, just subscribe to this channel, and make sure to share this video. And if you really like the concepts explained in this video, feel free to give a thumbs up and give us a feedback how we can improve this particular video further. And yeah, that's it for this lecture. See you next time.